2, covering chapter 15, is on the speed of sound. And the focus question, looking at resonance or vibration. So we don't really know too much about it because we haven't covered the chapter, but we do know something about amplitude and frequency. So as always, you can look through the notes to figure out the theory relating to this lab, and you'll probably need some if there's something else added to the lab. But it's saying how many standing waves of sound are present in a tube is resonance frequency. And sound travels in waves. So the thing we learned in chapter 14 was so we learned about that waves kind of travel in the sinusoidal pattern. So that's actually how sound travels as well. So this lab, the materials here, the experiment. So what we're actually looking at, just to demonstrate, is we're going to have, where did all the brush was over there? So we're going to have this tube here. So you have water, and you have a tube. Whoop, all right, like that. And some sound traveling in a wave, hitting the water, and then going back up. And what you're trying to figure out is what is the length of this wave. And you're trying to match the length right to get the loudest sound. So I'll demonstrate what's going to happen in this lab. So you have the equipment as specified. We have this tube full of water. You have a meter stick for which we're going to measure. We're going to measure the height from the water to the top of this tube here. You'll be holding this tuning fork right above. Now it's going to work. You need 2 people for this. So you're going to have this tuning fork, which you're going to hit with the mallet. You can also hit it with your shoe, but you hit it with the mallet, and you're going to hear this low grade frequency, something like that. You hold it right above the tube and listen to the sound. So you try to figure out where it's loudest.
If you do it again.
Oh, that's so cool.
So, someone, you want to come help me demonstrate here? All right. All right. So you're gonna hold this. All right. You're gonna hold that. I'm gonna hit it with the mallet. So I'm gonna hit it on the edge of the tuning fork. So you find where it's loudest right there. That's where it's loudest. So you hold it there, and you want to see what is actually the length in centimeters here. You want to see what is the length. I moved it a little bit, but there we go. You want to see what is the length of that water. So where the sound is actually stopping and hitting back up to the top of this tube. So that's what's interesting. So we're trying to find the length. All right, I'm good now. Thanks. You're a wonderful demonstrator. But so we're trying to find what is the optimal length to maximize the sound. Right? You guys heard that? Yeah, it's a pretty interesting lab. So let's look at the questions here. So there's an equation relating wave frequency, speed, and wavelength. So we'll take a look at that one. And you're going to want to use this equation that starts with a lambda there. So the resonant length of the tube. So where lambda is the sound wavelength, L, lowercase l, is the length of the air column, and D is the diameter of the tube. So I mean you can use the rulers to measure the diameter of this tube as well. So it says, do not strike the tuning fork any other way. All right, and it tells you how to do the last. And then so what you're really looking for in the end. All right, let's see. It says record the following measurements: average air column length. So you're going to do a few trials, obviously, and you want to see what is the length of the loudest sound. So you'll hit it a few times, reset it, bless you. reset it and see what that length is. Tube diameter, you just only need to measure once, or you can measure 3 times just to be sure with 3 different people. Wavelength you'll figure out, frequency you'll figure out, the experimental speed of sound, the theoretical speed of sound, and some percent error. So again, we use a formula to find our experimental speed of sound, and another formula to have our theoretical speed of sound.
That's an election notes?
The what?
The formulas for that's an election notes?
Yes. And that's pretty much it. So let's see. So you'll figure out how to find the natural frequency, how to find the wavelength of sound, how many standing waves, so how many times the wave repeated itself, how many periods are in the tube, and how to calculate speed of sound and percent error.